All right. Hey, good morning, biology class. So here's the video that I was promising you right before the quiz. I want you to go ahead and check this out. This is me going through the entire study guide. Before you take the quiz, I recommend watching this video, watching me go through the study guide, and then also practicing the quiz on the Kahoot. So the Kahoot I've made is a great tool to help you get your mind in focus and work on studying for the quiz. So without further ado, let's walk through this study guide. We're going to walk through this study guide real quick. It's not going to take too long because I'm not going to really go in depth. I'm just going to hit on what I think you should know. So up this like first slide is really nothing you guys had to do. It's just vocabulary. Make sure you feel comfortable with it. Remember populations. Populations are a group of organisms that are the same species, right? Like we have a group of lions, we have a group of humans, we have a group of wolves. A population wouldn't be a group of beetles, lions, and humans. No, it has to be the same species. So a population would be, like I said, a group of just beetles. Population growth is the different ways those populations can grow. They can rise, they can shrink. Population growth is just how they change. Population density, remember, that's very important to remember how this is. It's the amount of organisms per area of land. So if we have 15 humans per square foot, or we have 17 tigers per square mile, right? Remember that to do this calculation, to find out population density, and I'll even write it out, your equation for population density is the number of, whoa, that is terrible handwriting. Number of organisms divided by the area. And that'll give you whatever amount of organisms per area of land. Next, we have carrying capacity. Remember, our carrying capacity on the graph is the maximum amount of organisms a certain environment can sustain or hold. It cannot go above that carrying capacity because that is just, whoa, that's too much, right? That's the amount as we can hold. So over time, you'll see it level out. And a carrying capacity, remember, that's the maximum amount of organisms an environment can hold. Next, we have limiting factors. Remember, we talked about limiting factors a lot. What are limiting factors, what they do to a population. So recall, limiting factors are factors that just control the size of our population. So things like food availability, space, natural disasters, drought, hurricanes, floods, all those things will have an effect on our population and limit the population size. Oh, excuse me, that's embarrassing. Yawning so early. So, population graphs, are we able to identify the difference? So this graph right here, the one that shows no leveling, the one that just goes straight up, this is gonna be our exponential. And then describe what's happening. This is rapid growth with no signs of slowing down. Next one is our logistic. And this is rapid growth, then leveled off at a carrying capacity. So if you see a graph that has a carrying capacity, that is a logistic graph. That is logistic. Next, we have a few questions about birth rates and death rates. A few ways to increase the birth rates of the frogs might be to give them more food, right? Decrease the amount of competitive mates, right? Have more people there to mate. How does increasing the birth rate change the population size? Well, if we have more individuals being born, that means more individuals are being added to the population. So population size goes up if birth rate goes up. Give examples of things that might increase the death rate. Well, a drought. Frogs need water to live. So a drought would actually decrease the population, increase that death rate. Introducing a new predator, right? That might decrease the population by increasing the death rate. And I've already hit on it for part B. Increasing the death rate, if deaths go up, that means population size goes down. Next, we have immigration versus emigration and population density. Remember, for population density, all we have to do is we have to take our number of organisms and divide it by our area. So on the west side, let's say we have 20 skunks. We have 20 skunks, so that's our top of the equation, and it says the west side is 15 square miles. 20 divided by 15, right? And that's going to give us our population density. Same thing with the east side. Let's say we have 20. I don't actually know how many we have. I think there's probably around 20 here. 20 divided by 31, and that's going to give us our answer. Next, we're talking emigration versus immigration. Let's say I take this skunk right here. I take this skunk and it crosses over the river and joins this population. Now this population over here, this experienced emigration with an E. And that's because that population or that organism is leaving the population, it's exiting, so that is emigration. This east side over here is experiencing immigration with an I. Immigration because someone's joining the population, they're immigrating in. Very good. Next slide is all about carrying capacities. So for graph A, right, it looks like our carrying capacity, we can estimate, it looks like it levels out around 250 organisms. So we have 250 as our carrying capacity. Did the population change? Well, yes, the population grew and then it leveled out, and now it's not changing. It's pretty much just staying there. And did the carrying capacity ever change? No, the carrying capacity stays at 250 the whole time we see this graph. Next graph is a little more interesting. We see our carrying capacity sits at around 200, and then something happens that causes the carrying capacity to decrease. So let's say we added in more predators. We added in more predators, so all of a sudden there's more rabbits dying or whatever organism you want, right? There's more of those dying, so all of a sudden its population is brought down. Okay, cool. This right here, these are the differences between limiting factors, whether or not they're related to population density. So disease, this is one we didn't hit on a whole lot, but disease is actually dependent on density. It is related to population density. Big X in there. That's because, think about it this way, if we were, why are we not at school right now? Why are we not at school? And it's because if we had more people cramped in a room, cramped in an area, it's the easier for us to get sick. Same thing with everything else. The more organisms there are, the easier it is to transmit diseases. Temperature, do you think temperature cares whether or not there are a bunch of flamingos? No, right, no, they don't care. Right, temperature is not changed by the density of the population. Food availability, whoops. Food availability, however, is, and that's because, right, the more bobcats there are, the less food there is because there's bobcats competing for food. And then sunlight to a plants in a dense forest. This one's a little tricky because normally you'd be like, well, plants don't affect the amount of sunlight. But if you think about it, think about if I have 50 trees versus 10 in the same area. 50 trees is going to shade out a lot more than 10 trees are. So 50 trees are going to cover more area. There's going to be less sunlight. So this would actually be related to density. All right, last question is just how are you feeling? If you guys are ever feeling super stressed about this, or, you know, I've already worked some things out with people on extending the quiz time because they're having trouble getting it done today, you can always message me on Schoology. You really can. I want to do what's best for you. So if you think there's a better thing that I could be doing that'll help you succeed, you can always message me and let me know. If not, good luck on the quiz today. Don't forget, watch this video and then go through the Kahoot, which is about 15 questions, and then take the quiz, which is only 9 questions. I think you guys will do great. If you have any questions, you absolutely can message me. If not, I will see you all next week.